a few days ago I published a circuit where I mentioned it as a kind of bird sound generator. But I was searching further and especially trying to go to that typical chirp sound. And it succeeded. I had to do some study via the World Wide Web and adapted one of my earlier circuits that I published on YouTube to this chirp sound audio generator. So it mimics, in my opinion, better the typical chirp. This was the old schematic here, the old demo. I will give the link to that earlier schematic because it's also okay and it works okay, etc, etc. So it's what you need and what you like. But anyway, this is more or less the, say, more sharp sound, and it is given in a very simple circuit made with 2 transistors. I've used medium power transistors BD139 and BD140, and in fact it is of course again a classical A-stable multivibrator via which we can set the bias here via that 470 kilo ohm potentiometer, and we can set, say, the typical chirp sound that is generated by 2 electrolytics here. It sets in a certain way the delay time, and I've drawn it by purpose in this way so that it is clear for everyone. BD139 is NPN, BD140 is PNP, etc. This is the, say, the electronic schematic. And this is the drawing. So I hope that's enough. I want to demonstrate it with in two different situations. At first, connecting 3 batteries of 1.5 volts in series, so that we have here 4.5 volt. How does it work in that way, in that case? And furthermore, with my bench power supply to give it higher voltages. But of course, when you give it higher voltages, all kinds of unexpected things can happen. This 47 kilo ohm sets the frequency, and this this is 470 kilo ohm. Well, I have to take a small pause because that's a serious flaw. Before I have to do my video all over again. This is 470. So 470 kilo ohm, not 47 but 470 kilo ohm. And here we have indeed that 47 kilo ohm potentiometer that's here. So here with that 470 kilo ohm we set the frequency, and with this potentiometer here we set in a certain way the time delay, say the beep frequency, the chirp frequency. So let's look and see what happens when we do this experiment. So I've now connected here 3 batteries, 1.5 volt in series, together 4.5 volt. When I push the button switch, and this is what is on the scope. you see the effect of the electrolytic capacitor. It depletes, and it has, of course, because it's time dependent, it has an effect on the sound. Well, let me try to demo a situation where we can, in a certain way, set of course when I connect the battery directly, it starts to beep. I only want to do that to demo the different frequencies that can be generated. And then I mean the different frequencies of the birds chirp, yeah. So, turn the pot meter. Let's look at the scope. So here it stops, but here it starts. So, it sounds a little bit strange. But anyway, when you use a good quality pot meter here, you can set different frequencies. And here you can also set frequencies, but also the delay time. Of course, when I operate it now in a constant mode, I cannot demonstrate the delay times anyway. But anyway, let's try to turn this and see what happens. So this has also an influence on the frequency. And you can even see here that the frequency is more or less ultrasonic. There's no problem. And with ultrasonic I mean above, say, 20 kHz. You cannot hear them any longer. But of course you can hear that bird when it is singing its song. And you hear some noise here. Anyway, go back to the bird frequency. Oh, help. So here we are again on that bird frequency. Disconnect now the power supply. Let me demo it with, say, 12 volt. What is going to happen when we push the chirp button? At the moment nothing, but that is of course logical, because the potentiometers must be set first. So, this is 12 volt. And also here, turn it here. So you can also operate it on 12 volt. Let me demo the sound. Anyway, so the best demo is, in my opinion, with these batteries. 3 batteries in series. So let's go back to the basics. 3 batteries in series. Of course, at first I have to make it scream. So, here is, they are now here. The whole circuit is now on these 3, in fact quite old batteries, but anyway. Push the button switch. And you have to, that's very strange in my opinion, but anyway, when I push it quickly the first time, it doesn't oscillate, but when I do that in the second time, it starts to work. And after that it starts to work. So real fun, always interesting. to do these experiments? Well, not so much more to tell. These two potentiometer settings are critical. And that's logical. Very, very logical. So, anyway, finally the schematic again. And thanks for watching. I appreciate it. Not so much more to tell. I was inspired by a circuit on YouTube, but I could not get that right. So I had to go back to my earlier schematics of oscillators. And when you know a little bit about my YouTube channel, there are, I think, tens or hundreds of oscillator circuits on my YouTube channel. Both for radio, both for audio, etc. etc. So that was all. Thanks for watching. Again. Always fun to do these experiments.